Section 3.2 on the product and quotient rule. Okay, 1 to 35 odd, 41 to 49 odd is the assignment. So get that for you. So 3.2, the product rule and the quotient rule, page 183. It's not as easy as you might think. Let's go ahead and get to the homework. Okay, page 188, we have to go up to problem 49, it looks like. So here we are. So you can see there are some products and some quotients. So we have to do the product rule and the quotient rule. Some more on this side. Okay, anything with a graphing calculator icon, you don't have to do, since I'm not requiring you to have a graphing calculator. Here. And there we go. We have to go up to 49, it looks like. All right. We'll go back and pick up some things back again from section 1. A normal line is perpendicular to the tangent line. So here's a curve. Okay, that's a tangent line, that's a tangent line, that's a tangent line, that's a tangent line. So if I draw a line perpendicular to that, that'll be the normal line. So here are some normal lines that I've drawn here. The normal line is perpendicular to the tangent at the point of tangency. And you might recall that for two lines to be perpendicular, the product of the slopes is -1. M1 times M2 is equal to -1, or M2 is equal to -1 divided by M1. They are negative reciprocals for perpendicular lines. So for instance, y equals radical x at the point 1, 1. Here's the slope of the tangent line is 1/2, so the slope of the normal line would be -2. Okay. And here's also 3.1, number 31. Looks like this. First thing I'm going to do is write this as y to the -10th. A y to the -10th plus b e to the y. So the derivative of this is -10a. A is a constant, b is a constant. -10a y to -11 plus b e to the y. Bring the y to the 11th back down. So -10a over y to the 11th, b e to the y. This would be dz dy using the Leibniz notation. It tells you directly what the variables are, z and y. Okay, I want to clean that up. And now 3.2 for the product rule. So just some introduction first. So this is theory. Is it true that fg prime is f prime g prime? Okay. That's our first guess. That would be my first guess. So let's speculate. We know that x squared times x cubed equals x to the 5th. So is the derivative of x squared prime, plus the derivative of x cubed prime, is that question mark equal to x to the 5th prime? Okay, the derivative of x squared is 2x. Derivative of x cubed is 3x squared. Derivative of x to the 5th is 5x to the 4th. They are clearly not the same. So no, this is not the product rule. So what is f of x g of x prime? So here's a proof. So by the limit definition, limit h approaches 0, f of x plus h, g of x plus h, minus f of x, g of x all over h, okay, equals limit h approaches 0. That's the same, that's the same. And mysteriously, I subtract and add the same thing, minus f of x plus h, g of x, then quickly add the same thing, so that's 0. The reason why you want to do that is now I will factor here a common factor of f of x plus h. That gives me g of x plus h minus g of x. And here I factor out the common factor of g of x, and I have f of x plus h minus f of x. Okay? And then I'll use the rule that the limit of a product is a product of limits. Limit of a sum is the sum of the limits. So lim plus lim. Limit h approaches 0 of f of x. Limit h approaches 0, g of x plus h minus g of x all over h. Plus lim. Limit h approaches 0, g of x. Limit h approaches 0, f of x plus h minus f of x all over h. Here, as h approaches 0, you plug in, you get f of x. This is the very definition of g prime of x, plus limit h approaches 0, g of x. That doesn't depend on h, so g of x. This is the definition of f prime of x. Okay, so here is the real product rule. Fg prime is fg prime plus gf prime, the product rule. Okay, put this on your cheat sheet. Okay, the basic idea is you take the first function, multiply it by the derivative of the second, plus the second times the derivative of the first. It's a product rule. Fg prime plus gf prime. Okay, and well, now that we saw the product rule wasn't simply the product of the derivatives, you wouldn't expect that to be true for the quotient either. So f divided by g prime is not f prime divided by g prime. So what is it? So limit h approaches 0, f of x plus h divided by g of x plus h minus f of x over g of x all over h. Okay, divided by h means multiplying by 1 over h. Okay. F of x plus h over g of x plus h minus f of x over g of x. We've seen that game before. Multiply this side by g of x over g of x. Multiply this side by g of x plus h over g of x plus h. And now this stuff has a common denominator, g of x plus h times g of x. This is f of x plus h g of x minus f of x g of x plus h. And just like the previous problem, I'm going to quickly subtract and add the same thing because it works. Minus f of x g of x, and then quickly plus f of x g of x. So this stuff in red is 0. Okay, I decided to separate this out. So the limit of a quotient is the quotient of the limits. So limit h approaches 0 of 1 over g of x plus h times g of x. Then limit h approaches 0. I'm going to put this h down below. So this is g of x, f of x plus h minus f of x. And now I'm going to put plus f of x and turn this around. So factor out the f of x. Okay, and it says g of x minus g of x plus h. I'm going to turn it around. So if I turn it around, I get to multiply by -1 in the next step. So g of x minus g of x plus h. And the next step, this is 1 over, just plug in 0, g of x times g of x, 1 over g of x squared. Okay. As far as h is concerned, g of x is constant. That factors out. Limit h approaches 0, f of x plus h minus f of x. Okay. Minus, so turn this around, multiply by -1, and it becomes g of x plus h minus g of x, minus, and f of x is a constant as far as h is concerned. Take out the f of x, limit h approaches 0, g of x plus h minus g of x all over h. Okay. This is g of x. This is the definition of f prime of x minus f of x. This is the definition of g prime of x all over g of x quantity squared. So this is a quotient rule. Okay, summarizing, f over g prime, quotient rule, g f prime minus f g prime over g squared. You are not responsible for all this. I am responsible for all this. You just have to know this is the quotient rule and use it. Similarly, for the product rule, I'm supposed to show you a proof. Where does it come from? So here's where it comes from. You're not responsible for it. I'm responsible for it. You need to know product rule is fg prime plus gf prime. Quotient rule, the derivative f over g is gf prime minus fg prime over g squared. This kind of looks a little bit like the product rule, where you have one function times the derivative of the other minus the other way around. Big difference is that for the quotient rule, it's a minus, product rule, it's a plus. And then for the quotient rule, you still have to divide by g squared. There's nothing like that for the product rule. Okay. So in words, here's the quotient rule. You take the bottom times the derivative of the top minus the other way around, top times the derivative of the bottom, all over the bottom squared. Okay. All right, so we'll start doing some problems from 3.2. Number 9. Number 9, it says u minus radical u, u plus radical u. That one, it's a lot easier to just multiply it out. A minus b, a plus b is u squared minus u. So the derivative is just 2u minus 1. Okay, so no big deal. Okay, number 7 is a quotient, 1 plus 2x over 3 minus 4x. So it goes for the derivative g prime, bottom times derivative of the top, which is 2, minus, temporarily pretend it's a minus, I know I changed it to plus, the top, 1 plus 2x, times derivative of the bottom, which is -4. So that's a negative, and that's also a negative, so I'm going to make them positive. The next step, over 3 minus 4x quantity squared. Okay, just clean up the top. 6 minus 8x plus 4 plus 8x. 8x cancels out. Final answer is 10 over 3 minus 4x quantity squared. Okay, 17, y equals e to the p times p plus p radical p. This is p to the 3/2 power. Okay, so this is the first function, this is the second function. So the derivative is first function, e to the p, times the derivative of the second. The derivative of the second is 1 plus 3/2 p to the 1/2 plus second, p plus p to the 3/2 times the derivative of first, e to the p. Okay, and that's about it. You don't have to do more. I suppose you could factor out an e to the p, but that's good enough. Okay, 21 is a quotient, f of t is cube root of t, that's t to the 1/3 over t minus 3. So quotient root goes bottom, t minus 3, times the derivative of the top. Derivative of t to the 1/3 is 1/3 t to the negative 2/3, minus the top, cube root of t, times the root of the bottom, but that's just 1, all over t minus 3 squared. And we'll just leave it like that. 23 is more complicated. It's a quotient, but there's a product in it. So there's a product root inside a quotient root. Okay? So the derivative is the bottom, x squared plus e to the x, times the derivative of the top. But the derivative of the top is a product. So first, x squared times the derivative of the second, e to the x, plus second, e to the x, times the derivative of the first, 2x, minus the top, x squared e to the x, times the derivative of the bottom, 2x plus e to the x, all over the square of the denominator, x squared plus e to the x, quantity squared. And we'll leave it like that. Okay, 27 is a product, first function, second function. So the derivative is the first times the derivative of the second, derivative of e to the x is itself, plus second times the derivative of the first, e3x squared. Okay, this one, it's worth it to factor out the e to the x. So factor out e to the x, x cubed plus 3x squared plus 1. Okay. Then the second derivative, f double prime, first function times the derivative of the second, e to the x, plus the second e to the x times the derivative of the first, 3x squared plus 6x. And again, factor out the e to the x. I have x cubed plus 3x squared plus another 3x squared is 6x squared plus 6x plus 1 times e to the x. 35, they want the derivative at -1 comma a half. Y equals 1 over 1 plus x squared. So bottom times the derivative of the top, but the derivative of the top is 0. I like that. Minus the top times the derivative of the bottom, 2x, all over 1 plus x squared squared. Clean it up, -2x over 1 plus x squared squared. Now I plug in -1. So -2 times -1 over 1 plus -1 squared. -1 squared is 1. 1 plus 1 is 2. So I have 2 over 2 squared, which is 2/4 or 1/2. Okay, so point slope form, point slope, y minus y1 equals m times x minus x1. Okay. And that is that one. And let's see, yeah, something back in, going back to 3.1 again. So here's something from 3.1. P equals K over V, problem 53. So I plug in 50 here, 0.106 here, okay, multiplied by 0.106, K is 5.3. So P is equal to K over V. I'm allowed to switch these two around from algebra. So V is 5.3 over P, or 5.3 P to the -1. dV dP is -5.3 P to -2, or -5.3 over P squared. Okay, then I plug in 50. So dV dP is -5.3 over 10 squared, -0.00212 meters cubed, that's the units for volume, divided by kilopascals, that's the units of pressure. Okay, 59, you have this function, and they want parallel to this line. So first I need to find the slope. So move over the y, subtract the 15, 3x minus 15 equals y, so the slope is 3. So if I want parallel to this line, I want the slope also to be 3. So I take the derivative and set it equal to 3. So y prime is 3x squared minus 6x plus 3, set it equal to z, 3. Subtract 3 on both sides, 3x squared minus 6x equals 0. Factor out the 3x, 3x times x minus 2 equals 0. That gives me x equals 0 or x equals 2. And they ask for points, so just plug in 0 and 2. Plug in 0, that's easy, 0, 0, 0, minus 3. I'll let you plug in 2 on your own. That's a little bit harder. Okay. Okay, going back to 3.231, y equals x squared minus 1 over x squared plus x plus 1 at the point 1, 0. So quotient rule, bottom times derivative of the top, 2x, minus the top times derivative of the bottom, 2x plus 1, all over at the bottom square. Plug in 1, 1 plus 1 plus 1, 2 times 1, minus 1 minus 1 is 0, so that gets wiped out, over 1 plus 1 plus 1 squared, that's 3 squared. So I have 3 times 2 over 3 times 3, 6 over 9, or 2/3. Okay. Point slope form, y minus y1, which is 0, equals 2/3 times x minus 1. And you can just stop right after that. Okay. All right. Some more from 3.2. 41, f of x is x squared over 1 plus x. They ask for f double prime of 1. So the first derivative is bottom times derivative of the top minus the top times derivative of the bottom, which is 1, over 1 plus x squared. Clean it up. 2x plus 2x squared minus x squared, or x squared plus 2x all over 1 plus x quantity squared. Double prime, bottom times derivative of the top, 2x plus 2, plus the top times derivative of the bottom. Okay. This, if you multiply it out, it's x squared plus 2x plus 1. So the derivative is 2x plus 2 all over 1 plus x to the fourth. Okay, now they tell me to plug in 1. So f double prime of 1, 1 plus 1, 2 times 1 plus 2, 1 plus 2, 2 times 1 plus 2 over 1 plus 1 to the fourth power. Okay, that's 4 times 4 plus 3 times 4 over 2 to the fourth. So that's going to be 16 plus 12, 28 over 16, 7/4. Okay, 43. Okay, f of 5 is 1, f prime of 5 is 6, g of 5 is -3, g prime of 5 is 2. So that's all given. So they say f g prime of 5, or f g prime of x is f of x g prime of x plus g of x f prime of x. Now you just plug in 5. f g prime of 5 is f of 5 g prime of 5 plus g of 5 f prime of 5. Just plug everything in. So f of 5 is 1, g prime of 5 is 2, plus g of 5 is -3, f prime of 5 is 6, grind it out, -16. Something similar for b, f over g prime of 5. So it's g of 5, bottom times the derivative of the top, minus top times the derivative of the bottom, all over g of 5 squared. And you just plug in. Okay, g of 5 is -3, f prime of 5 is given to be 6, minus f of 5 is 1, g prime of 5 is 2, all over g of 5, -3 quantity squared. So that's -18 minus 2 over 9, -20 over 9. Here's 45. f of x is e to the x, g of x. Say g of 0 is 2, g prime of 0 is 5. Find f prime of 0. F prime of x is first times derivative of second, e to the x times g prime of x, plus second g of x times derivative of first, where the derivative of e to the x is e to the x. Okay, plug in 0. F prime of 0 is e to the 0, g prime of 0, plus g of 0, e to the 0. E to the 0 is 1, e to the 0 is 1, g prime of 0 is given to be 5, g of 0 is given to be 2, so 5 plus 2 is 7. 47, g of x is x f of x. They give me f of 3 is 4, f prime of 3 is -2. Give the equation of the tangent at x equals 3. Okay, so I plug in 3. G of 3 is 3 times f of 3. 3 times 4 is 12. So the order pair is 3, 12. Okay, g prime of x, product root. First times the derivative of second, x f prime of x, plus second f prime of x times the derivative of first, which is 1. Plug in 3. 3 f prime of 3. G of 3 is 3. G of 3, yeah, we already did that. G prime of 3 is 3, f prime of 3 plus f prime of 3. So it's 3 times -2 plus -2, that's -8. So the slope is -8. Here's the point. Y minus 12 equals -8, x minus 3. Okay, 49, you have to use the picture. U of x is f of x, g of x. So u prime of x is first times derivative of the second, plus second times derivative of the first. U prime of 1 is f of 1, g prime of 1, plus g of 1, f prime of 1. Okay, so f of 1, f of 1 is 2. G prime of 1 is 1. G prime of 1, slope. Sorry, g prime of 1 is -1. At g of 1, what's the slope? The slope is -1. Then g of 1, the function value for g at 1 is 1. F prime of 1 is the slope at 1, that slope is 2 over 1 and up 2. Okay, so you get 2 times -1 plus 1 times 2 is 0. Okay, and something similar for v prime of x, g of x f prime of x minus f of x g prime of x over g of x squared. Okay, so g of 5 is 2, f of 5 is 3. G of 5 is 2, f of 5 is 3. What about the slopes here? G prime of 5, slope here seems to be over 3 up to 2/3. And what's the slope at 5 for f? That's over 3 down 1, so -1/3. So G of 5 is 2, f prime of 5 is -1/3 minus 3 times 2/3 over G of 5 squared, 2 squared. So -2/3 minus 2 all over 4, multiply top and bottom by 3, -2 minus 6 over 12, -8/12, -2/3. And then 33, y equals 2x e to the x at 0, 0. So derivative is first times derivative of second, e to the x, plus the second e to the x times derivative of first, which is 2. Plug in 0, that's gone. That's going to be 2, so 2, that's my slope. So for the tangent line, y minus y1, 0, equals m, 2, times x minus x0, which is also 0, or y equals 2x. The normal line, just give me the perpendicular slope for 2 would be -1/2, negative reciprocal. So y equals -1/2 x would be the normal line. Okay. All right, so that was 3.2 and a little bit others of 3.1 also.